This is Math 217, Lecture 9 on the relationship between two categorical variables. We've talked about the relationship between variables before. I want to remind you a bit and do a little review before we start talking about the details of measuring the relationship between categorical variables. So I'll remind you that if we are interested in whether one variable affects another, we call the variable that we are considering might do the affecting the explanatory variable, and then one we think might be affected the response variable. Remember also that two variables are associated if for certain values of one of the variables, the chances of values of the other variable are higher than for other values of the first variable. Kind of a mouthful. Roughly speaking, knowing the value of one variable gives you some information about the value of the other. And recall, seeing an association in an experiment implies that the explanatory variable affects the response variable, but in an observational study it might not. The reason is because of lurking variables. So let's go through an example very carefully. We'll review the 5 steps of study design and some of the important concepts we've talked about, and then we'll use that as our first example. So let's take as our initial question whether gender affects your political views. So to turn that into a precise question, let's first take our population to be Fairfield U students. And then we are going to take as our variables gender, of course, and then because political views is too fuzzy to be a variable in itself, let's take political party as a stand-in for your political views. Okay, so the precise question is, does gender affect political party in Fairfield U students? I'm going to ask you some questions. You should pause the video unless you can see the answer right away, so that you can decide the answer for yourself, maybe write it down, and then compare it to my answer to make sure that we're together on this. So first question, what type of variable is gender? It is a binary categorical variable. Categorical because there's multiple choices, the answer isn't a number, and binary because there's of course only 2 possibilities. What type of variable is political party? That's a little bit subtle. Of course it's a categorical variable, but how many choices there are, whether it's binary or not, depends on how many choices you give. You could just say Democrat or Republican and then it would be binary. If we stick to the wording that I gave on my survey on the first day of class, there were 3 choices: Democrat, Republican, Independent. Of course, I could have offered more options. There's the Constitution Party, the Green Party, there are dozens of very small parties. One of the decisions you have to make when you're designing a study is how many choices to give, how to lump together the other possibilities so that you don't have to deal with extremely rare occurrences like members of the Constitution Party, which can make it harder to draw conclusions. Okay, and finally, in this page, which variable is explanatory and which is the response? Gender, of course, is the explanatory, party is the response. That's because we said that you want to know if your gender influences your political views. So that sentence gives it away. In fact, in this case, it wouldn't really make sense for political party to affect gender. Great, so step 1, precise question, we're all clear on that. Step 2 is the sampling design, and step 3 is the measurement. I'm going to take, for my sampling design, the survey I gave at the first day of class, but because I don't have all of that data yet, I'm going to go with the survey I did to my sections of 217 in 2011. So I believe it was 3 sections then of 217 is the sample. The measurement is that survey that I gave on the first day of class. Okay, some more questions. Is that a random sample? No, it's a convenience sample. Why? Because not everybody is equally likely to be chosen. Some Fairfield U students, the ones, for example, who don't take Math 217, will never be chosen. All right, given that it's not a random sample, there's the possibility for sampling bias, and I'll remind you that a sampling bias, to identify a sampling bias, you need to identify a group more likely to be chosen and identify a direction in which that's likely to shift a variable. Technically, it's a direction in which it's likely to shift the parameter that you're measuring. We haven't yet talked about what parameter we would measure, so let's just, for now, imagine ways in which it would shift the response variable. This is going to be a little bit hypothetical for you, since you may not know what kinds of people are more or less likely to be chosen, in particular more or less likely to show up in my Math 217 classes, but do your best to come up with some plausible guesses, and we'll see how they compare to mine. All right, one group that I know is more likely to be in Math 217 is business students. So I have to identify that's a group more likely to be chosen. I need to identify a direction in which they would shift the response variable, which is the political party. I am going to guess that business students are more likely to be conservative than general Fairfield U students. That fits at least the stereotype of business students. Another group, this was less true in 2011, but now another group that's more likely to take Math 217 is nursing students. You might think nursing students are more likely to be liberal than the typical Fairfield U students. That would be a fine answer too. Other possibilities, I generally teach in the morning, and that semester, as it happened, I taught very early in the morning. You might argue that people who take morning classes are going to be more conservative because they're more comfortable with this kind of structure of getting up early in the morning. Are those all really true? I don't know. The important thing is to identify at least vaguely plausible ways in which it might shift the variable. You should think of this as brainstorming. Think about possibilities that might lead to sampling bias. It's much more important that you can think expansively about what the possibilities are than that you think sort of deeply critically about how likely they are. Once you've thought up the possibilities, it's much easier to say, yeah, I don't think that's a big deal in this case, or to investigate whether or not it's a big deal in this case. All right, measurement bias. Remember that for us, the most common form of measurement bias is leading questions. We don't know any here, and response bias. Here, as I said, there isn't really any room for me to ask a leading question. You know what the question looked like, and there was nothing leading about it. It was what political party did you have? But there is the possibility for a response bias because people may answer what they think I want to hear. And a reasonable guess, since most college professors are liberal, is that I'm a liberal. So maybe you would be afraid to say that you're a Republican for fear that I would disapprove or lower your grade or something. I won't. Is this an experiment or is it an observation? And why? It's an observation, or observational study is the correct way to say it. The reason is because we did not assign genders. In fact, I don't know how you could randomly select half the people and assign them a gender, short of some kind of surgery. That's the reason. Doesn't matter what you're doing to affect people or control people. It only matters whether you assigned values of the explanatory variable. And finally, here's the perhaps trickiest question. What are some possible lurking variables? Remember, a lurking variable needs to be a variable, so different values for different members of the population. It needs to affect the explanatory variable, and it needs to be related to the response variable. This is a tricky case. There's none or no plausible lurking variables. Why? Because there aren't any variables that can affect gender. The only exception I can think to that is in frogs. Apparently, the temperature of the water in which the eggs gestate can influence the gender of the frog. But short of that, nothing is going to affect your gender, so there isn't the opportunity for lurking variables here. We're in an unusual situation where if gender correlates with something, it is safe to assume that gender is affecting that something. Now, the mechanism for the affecting, is it genetic? Is it environmental? Is it tradition in our culture? That obviously we cannot tell. Okay, so that's going to be our example, that hypothetical study about gender influencing political party. So how would you summarize the data? Remember, with one categorical variable, all you could do to summarize the data was to say how many individuals answered each possible answer. And the best way to express that was in terms of proportions. Similar things are going to be true here, but now, to summarize the data, we want to say the number of individuals with each combination of values of the explanatory and the response. So that gives you a table or a rectangle of numbers. So we call that a contingency table. So we make a table with the rows labeled by the values of the explanatory variable and the columns labeled by the response variable. So that's a convention, rows explanatory, columns response, that you should follow. And you should check, because it's not a universal convention, you should check to make sure it's being followed when you're looking at someone else's contingency table. So in this case, the explanatory variable is gender. So female and male are labeled as rows, and then the columns are labeled by the values of the response variable political party, Democrat, Independent, Republican. And then in each cell, we're going to put how many individuals had that combination of values of the two variables. So in my sample, 12 women said they were Democrats, 5 men said they were independents, and so on. You don't need to, but it's generally, for everything else you do, it's useful to have the totals. There are a bunch of totals. There's the total of each row. So the total of these three numbers, 12, 14, and 20, is 46, the number of women in my sample. The sum of 5, 5, and 11 in the second row is 21, the number of men in the sample. And likewise, underneath each column, I have the column sum, which tells you the number of Democrats, the number of independents, and the number of Republicans. And if I add up the row sums, or I add up the column sums, I get the total in my sample. There were 46 women and 21 men. That makes for 67 students in my sample. So it sounds like it was, in fact, 3 sections. Oops. Right, so 46 is the total of women, 31 is the total of Republicans, 67 is the total number of people in the survey. And now, just like in one variable, we found that proportions was the most useful parameter or statistic to summarize what was going on usefully. Here we're going to look at proportions, but it's a little more complicated. We can certainly talk about individual proportions. So, for example, we can ask what proportion in of the total survey were independents. There were 19 independents in my survey out of 67 students, so 28.4% of my sample was made up of independents. There were 21 men out of 67, so 31.3% were men. And we can also find the proportion of combinations. How many Democratic women were there? There were 12 Democratic women, so dividing by 67, I find that the proportion of Democratic women was 17.9%. Those are called absolute proportions when you divide by the total in the sample. None of those tell you whether the variables are associated. Right? Knowing what percentage of women there are, or even knowing what percentage of women Democrats there are, doesn't tell you if women are more or less likely to be Democrat or Republican or independent. For that, you need conditional proportions. What's a conditional proportion? It's a proportion given by dividing each cell by the total for its row. When I say the total for its row, I'm basing that on the convention that the rows are explanatory variables. So it's each cell divided by the total for its value of the explanatory variable. So in this case, the conditional proportion of Democratic women is the number of Democratic women, 12, divided by the row total, 46. So 12 Democratic women out of 46 total women means that 26.1% of the women are Democrats. Okay? Kind of a subtle thing. Stop and make sure that you see that that's what we're saying. The conditional proportion here is the proportion of women who are Democrats. Okay? By the same token, if we take the 5 Democratic men and divide by the 21 men, we find that 23.8% of men are Democratic, or Democrats. If we take the 14 women independents, divide by the 46 total women, we get 30.4%. If we take the 20 female Republicans and divide by the total 46, we get 43.5%. Why don't you pause the video and fill in the last 2 holes? Should be straightforward. Here's what I get, 23.8, 52.4%. Notice that apart from maybe a little rounding error, the rows should each add up to 100%, right? Because the percentage of women who are Democrats plus the percentage of women who are independent plus the percentage of women who are Republican adds up to 100% of all women. But the columns don't add up to 100%. Okay, so what did we learn here? We learned that, for example, 30.4% of women are independents, but 23.8% of men are independents. Likewise, we learned that 43.5% of women are Republicans and 52.4% of men are Republicans. And really important point, it doesn't tell you what percentage of Republicans are men. You get that by dividing by the column totals, and I think you'll agree that's not as helpful a way to talk about it. It's not as helpful because we can directly compare different values of the explanatory variable. We can say that, evidently here, women are more often independent than men, and men are more often Republican than women. And maybe women are slightly more likely to be Democrats than men. And those tell you the relationship between the variables. Right? That immediately tells you that women are more likely to be independent, less likely to be Republican. It tells you, in the best possible terms, what the relationship between the two variables are, and in fact, that in this case, the variables are associated. Knowing somebody's gender gives you some information, not complete, but some information about their political affiliation. So, as we said, except the sentence is backwards, right? Being independent is more likely for a woman than for a man, so the variables are associated. Okay? What we're basically look at in general is you look in each column, and if there's a difference in any column, they're associated. If it was the same number, 30% of women were independent and 30% of men were independent, then you would say knowing the gender doesn't tell you anything about whether somebody's independent, so they are unrelated, or we'll say independent. If in each column the conditional proportions are the same, then the variables are independent. And in that case, knowing the value of one variable would not tell you anything about the value of the other. So independent is the opposite of associated. This is all about this sample. What we haven't discussed yet, and won't for a while, is whether the relationship we see in this sample is likely to hold in the population. Maybe the next sample we took would have a couple more independent men, a couple fewer independent women, and this effect would disappear. That's a question we'll address later in the semester. All right, here's what you should have learned from this lecture. So right now, you should be able to make a contingency table, putting the explanatory variable in the rows and the response variable in the columns. If you had your pile of surveys, you should be able to find absolute and conditional proportions. Absolute proportions, you divide the number in a cell or in a row or column total by the grand total. Conditional proportions, you divide the number in a cell by the row total, assuming you've put explanatory values on the rows. And finally, you should be able to interpret absolute and relative proportions. Be able to say things like, that percentage there is the percentage of women who are independent. And you should be able to judge whether the data shows independence or association and know what independence and association mean. Well, I guess I put down identify independent association from the relative proportions as a advanced task, but it's somewhere in between.